The last video was solving systems of equations by graphing, and now we're going to get into solving systems of inequalities by graphing. Okay, so let's start with these inequalities. We've got y is greater than 2x minus 4, and y is less than or equal to negative 0.5x plus 3. So just like we did with the systems of equations, we're going to graph both of the inequalities on the same coordinate system. So for our first inequality, y is greater than 2x minus 4, I have that one dashed in pink. So it's dashed because it's strictly greater than, it doesn't have the equal to. And then we need to shade one side, right? So we've got, if it's greater than, we're going to be shading above. So above would mean if you have your finger or pencil on the line, it's above, right? So we're going to shade all of this up here. It's shaded. Cool? So we got that. Then for the second equation, or the inequality, it's going to be in blue. And it's this line right here. Beautifully straight line. Can't you tell? So straight. Awesome. Okay. And then it is less than. So less than or equal to. So it's a solid line because it has the equal to. And less than, if you have your pencil on the line and you draw a line straight down, that's the side you're going to shade. So we're going to shade anything below blue line. Alright, so now it just kind of looks like a bunch of scribbles all over the place, and that is kind of what it looks like. But, so we're talking about solutions, right? We've got the solution to one of the inequalities. The pink inequality is anything that's in pink, right? The solution to the blue inequality is anything that's in blue. But the solution to the system of inequalities is anything that overlaps. So if I'm looking at my graph here, I want to see where my my inequalities are overlapping, right? When we had just systems of equation, we looked for where they intersected, but that's not the case necessarily when we're looking at inequalities. We're looking at where they are both pink and blue. So over here is where they're pink and blue. So I'm going to shade that in a darker pink. Boom. That is our solution. So we have this where it's including this line right here, right? So we've included the blue line and we've dashed this pink line, and that is now the solution. Let's go ahead and take a look at another example so we can get this in our brains. And we have y is greater than or equal to x plus 5 and y is less than x minus 4. So first things first, we need to graph both of these on a coordinate plane. Okay, so we've got our first equation written in pink, and if we're talking greater than, so y is greater than or equal to, it's a solid line, and you put your pencil on the line and go up because it's greater than. So we're going to shade this side. Bleep, 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 bleep. Boom. And then we're going to do the other equation in blue. And it is less than, not equal to, so we've got a dashed line here. Dash, 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 dash. Okay. So we've got a dash line. And it is less than. So if we put our pencil on the line, it's less than, they are below. People that are less than you are below you. That's a bad analogy, but that is what I'm going with. They are below you. So we're going to shade this way. So, based on the last example that we did when we were trying to find our solution, what was our solution? It was the part that overlapped. So what do you notice in this? Well, I notice that they do not overlap. There is no overlapping. So, therefore, there is no solution. No solution. And if you remember from the video before, when we had no solution, it was because we have two parallel lines. There's no solution. There was no intersection, right? There was no intersection point. So there is still no intersection point in this one. So therefore, we don't have any solutions. Boom. However, if we change the problem a little bit, I changed the inequality right here to less than or equal to instead of greater than or equal to. So it's not always the case that if we have parallel lines, you're never going to have a solution with inequalities. That is the case with equations, but inequalities not so much. And here's why. So if we have y is less than or equal to x plus 5, this one is going to be in pink. And if it's less than, we got our finger on the line or our pencil on the line, and we draw a line down because they're below us. We shade that side, right? So that's that side. Then we're going to have our other equation in blue, and we have a dashed line again. Boom and boom. Then it's less than again, so we put our finger on the line and draw a line below, and we've got less than. And what do you notice? We do have some overlapping. So in this case, with inequalities, this right here is our solution. We do have a solution. As long as the signs are the same, or they're both less than or equal to, or both less than. So you'll notice that there are a lot of similarities when graphing just regular equations and inequalities when you're graphing them individually, and there's a lot of similarities when graphing systems of equations and inequalities. It's always good to remember that when we're dealing with inequalities, that's when we're shading things, but equations are just lines because their solutions are different. Does that make sense? So with inequalities, our solution is any point in this area right here, any point. Not along this line because it's dashed, right? So we can't have a point along that line. But any point in here, we could plug it in here, and they would satisfy both of the equations.